All right. We're going to talk now about a few odds and ends advanced topics. So we're just calling them other considerations. And some of these we've touched on in different talks already today, and some of them we're going to take a little bit further. And probably they're going to generate more questions, which is why we wanted to have a bigger question session after we finished everything. So again, we'll get back to the questions that we didn't get to in Brian's talk and anything else you have. So let's talk about, first, we're going to talk about acidification. Get up here, too many slides. And basically, this is not a chemistry lesson, but it's come up a couple of times, the importance of solutions and the soil and just all of these issues that affect the activity of our plant growth regulator in the solution when we apply it. And we know that the form of those PGRs is going to be affected by pH, some more than others, which is why we need to pay attention to that. And this is a table that I put together last summer, basically information from different labels from different chemical companies, and it was based pretty much on some work that Rick Yates and Griffin had done in putting together this as well. And they have a publication for all the pesticides that they work with. But I want you to particularly pay attention. You're very familiar with Ethifon. We've talked about that a couple of times. You know that that solution needs to stay below 5. What you may not know is that benzoadenine needs to stay below 8, or that dikegulate sodium needs to stay above 5.5. Now, as I think Brian mentioned, most of these compounds come in a buffered solution that will keep it in the range they want it to be applied in, as long as your water is within that normal irrigation range. You really should only have a problem if your water is out of that range. If it's very high alkalinity or very low alkalinity, you can get out of this range. And we talked about Ethifon in particular, that under high pH conditions, the chemical form changes and it releases that ethylene. And it will release it either in the spray tank or as it's being sprayed, and it doesn't get absorbed by the plant. What we really want is the Ethifon itself to be absorbed by the plant and then the ethylene released inside the plant. And the acidifiers in Ethifon will keep it down below a pH of 5 if your alkalinity is not too high. And we talked about some of the products that you can add as a buffer to get your spray tank down to a pH of 5 before you add the Ethifon. So let me just show you a couple of examples here. This is cholate. We applied it at a final pH of 2.6. And this was, I mentioned earlier that our water here at Virginia Tech is very low alkalinity, a pH of 7. When we added the normal solution at a part per million of 500 parts per million, the pH of our spray solution was 2.6. We had a lot of ethylene activity. We have increased branching. We did not have a delay in flowering, but we had a lot of branching on these plants as compared to adjusting that pH up to 6.9, above that 5. So we had very little activity from the Ethifon itself. We had no branching, no effect. However, the pH of 2.5 or 2.6 damaged the plants. So that's why someone asked earlier, what do you want that final pH to be? You don't want it as low as it'll go. You want to stay up more above that 3.5 or 4 so that you don't damage the plants directly with that low pH. So we have also done some work. As I said, we're interested in the liner dips and the drenches with cholate. So we started thinking about, well, what effect is the media pH going to have on the activity of the cholate or Ethifon in the media? So we did a study where we adjusted our pH of the media with lime from a range of 4.5 up to 7. And we applied cholate at 100 parts per million, which had a pH of 4.2. So our controls were grown in the pH range, and they were treated with water adjusted to pH 4.2. The cholate drench was at 100 parts per million, and these were in trade gallons, 10 fluid ounces per pot. And we applied that 1 week after we transplanted the plants. This is for Bina bonariensis. This is at 4 weeks after the treatment, 4 weeks after we drenched these plants. The top row here is our controls. They were treated with acidified water only, no ethifon. You can see that the pH of the media had very little effect on the growth of the plants. Now I've tried to adjust these pictures so that the pots are about the same size, so you can see the difference between the plant growth with the plants that were treated with the 100 parts per million cholate as a drench. And you can see that the cholate had a very significant impact on growth and development. We had a significant increase in branching, a lot of growth regulation on these plants. Now, if you look at them just a little bit later, this is 6 weeks after, again, no effect of the pH on the untreated plants. The cholate treatment was very significant, but I want you to look at the difference in the pH. When we had a pH of 4.5, which would keep the ethifon intact as ethifon, we had a greater effect, greater efficacy of the ethifon on that treatment. So cholate caused more growth reduction and more branches when the media pH was at an acceptable level to keep the ethifon in solution. So as we got into a higher pH up to 7, we had more rapid release of the ethylene in the plant or in the media, and therefore available to the plant, and a less long-term effect, a less effect overall. But still, we had a major impact of the ethifon at that rate, at that pH, and at that 100 parts per million. So I say all this to tell you that you need to work these rates and application methods out under your own conditions. I can tell you that over any pH range that we would normally grow at in the greenhouse, your cholate drenches will be effective. The degree of that effectiveness is going to depend a little bit on what that actual pH is. So you're going to need to work it out under your own conditions. Do your own trials. You'll hear that over and over again. Okay? All right. We talked a little bit about volume and the importance of the volume in terms of having the application uniformity. And for those of you, I think most of you are been here the whole time, so I won't dwell on this, but I apply it evenly to the area, not to the plants. I showed you this picture earlier talking about the volume we applied, a label recommended volume or a high volume. In this study, we also looked at ultra low volumes using a fog sprayer and an electrostatic sprayer. So we had a difference here in the spray droplet size and the volume. These plants showed a plant growth regulator response. You can see they're darker green. In this study, we had a significant increase in the number of leaves produced with the bonsai treatment, and these plants showed that as well. But we did not have anywhere near the growth reduction, the growth regulation that we had with the bigger droplet size and higher volume sprays. So we took this study one step further, doing a comparison between bonsai, a soil active material, and B9, a foliar applied, not soil active material. And you can see with the hand sprayer, which is what we were typically using, we got the label recommended volume, 2 quarts per 100 square feet. We got a significant growth regulation with that treatment. However, with the ultra low volume sprays, these are two different electrostatic sprayers and the fog sprayer, with the bonsai we essentially had no growth regulation. Again, we had a little darker green. We could see we had some response, but not the growth regulation we were looking for. If you compare that to the foliar spray, it didn't matter how we applied the B9. It landed on the leaves, it gave us activity on the leaves, and we had the same amount of growth regulation. So we came back to deciding that we had to look at droplet size. First of all, we were not getting runoff. We were not getting much of this material on the soil surface or washed into the root zone. And so that was a significant part of the treatment, of the actual application, that we were not getting with this type of a sprayer. So again, it gets back to determining a protocol, the droplet size you're going to use and the volume you're going to use, so that you can predict the response that you're going to have. And again, that is much more critical with the soil active materials than it is with those that are not soil active. If you are a true newbie with PGRs, you're going to want to start with these that are not soil active. They're much more forgiving and very effective on a very wide range of crops. So droplet size and spray volume are very important to activity. And just what I said, again, a lot of it has to do with how much of that material we're getting into the root zone because it is so available to the plant through that mechanism. Right, drying conditions. Brian mentioned this a little bit earlier as well. If we want to improve absorption, we want to look at conditions that allow for very slow drying after application. Cloudy days, early morning, late afternoon, moderate temperatures, high relative humidity, and limited air movement. Okay, for different materials, we still have different amounts of time that it takes for that material to be absorbed by the leaf. And Brian mentioned a couple of these that are very quick. And when we talked about the ethifon and dimenoside that are very slow to be absorbed by the plant. And our benzoadenine falls in this range as well. So we can get a very different kind of response depending on the drying conditions when we make those applications. Now, this was never so important or never brought to my attention so clearly as it was last summer. We did a rate trial early in the year in April on Heliopsis, and we did configure applications up to 1,200 parts per million. Not what you're normally going to use, but this was a rate trial. We wanted to get to the high range. At 1,200 parts per million, we had no phyto, and we had an improvement in branching. But look at our conditions. We were very dry. Relative humidity is very low. Pretty high temperature, so we have very rapid drying conditions. Under rapid drying conditions, configure, ethifon, dimenoside are all going to have very low efficacy. So we did not have much response here. We came back in July to do subsequent trials based on our rate trial, and I really was not willing to do 1,200 parts per million, but we did drop it down to 9. But look at our application conditions. 92% humidity, 72 degrees early in the morning before the greenhouse gets opened up. And we had very long drying times. We had severe phyto on these plants. And it had to do with the amount of active ingredient that was absorbed on those plants during that period of time. So I talked to my growers this week and gave the similar talk. And they're like, well, I can't keep track of that. And I understand that, because you kind of make your applications when you need to make your applications. But what I would caution you about is to avoid extremes unless you make a plan for it. One of our growers said that with his ethifon treatments, he actually makes the application and then runs the mist boom over those plants every 30 minutes for the next several hours so that he gets maximum absorption of the ethifon. So you can plan on that. If you can plan on the time and the conditions that you're going to make your application under and get the absorption time that you're looking for, that's excellent. If you can't, then I would just recommend you avoid the extremes so that you can get some predictability of your activity and your risk for phyto. Now, I seriously doubt we would have had this problem at 300 or 600 parts per million. But still, this is one extreme compared to a very different extreme. So if you can avoid the extremes, you'll limit your phyto. Longer drying times, increase absorption, that can be good or it can be bad. So you just need to pay attention to that. So if you can't keep the records, avoid the extremes. All right, saturation of responses. We talked about this a little bit too. What we really want to see is a linear response. What we often see is actually a saturation response. This is top floor, and the previous one was Sumagic, which really, it depends as much on the crop as it does the product. And I mentioned that we go to multiple applications to try to avoid that. And sometimes, as in this Monarda, we find the top floor, the recommended rate was 75 parts per million, 37 also saturated that response. And then there are extremes where the plant, this is a cultivar issue, where a 0.5 part per million drench at 10 fluid ounces per pot was okay. Gave us a little bit of growth control, not a whole lot. 1 part per million completely zapped the plant. So when plants are this sensitive to a drench application or to that product, I would either move to a different product or I would not use a drench on these plants. the issue with volume and the potential for doing a application that is overdosing the plant is just too high if they have that much sensitivity to the rates you're using. You might want to just stay with the spray applications, a little more control there. Another example here is salvia. This is another one that we kind of saturated the response with these higher rates. This was actually some work done in Georgia. And when we were there, we were growing all of these plants out in the landscape to see what kind of persistence we had. And this is those same salvia, the 60 part per million plants, never grew out. This was 3 months in the landscape in Georgia, and they never grew out of that. Just a spray application. There wasn't even a liner dip or drench. It was a spray application. They never grew out. So there are issues. There are still issues out there with overdosing. Some of those you're going to be aware of. You do something like this, it's going to get back to you through your customers. Hopefully you're not going to be that extreme. We're much better now. We have a lot more information on the rates. But I guess I would say if you're using a new crop, if you're testing PGRs on a new crop, grow them out or ask somebody to grow them out or ask for feedback so that you know that your rates are not too high. And it's not just with the soil active material. These were Heliopsis grown in the nursery that were extremely sensitive to diminizide. 2 treatments of B9 gave us excessive growth regulation, and we did not plant these to the landscape, but we held them in the pots, and they did not grow out of this, whether it was the B9 alone or in the tank mix with Cycocel, a single application. They did not grow out of that treatment. So it's not just the soil active materials. But we do have to deal with PGR overdoses, and that's come up a couple of times today. One is just recognizing that you have an overdose, and sometimes the growth may just be excessively stunted. It may be, you may think it is, may not be sure, but it's important to recognize what those overdose symptoms are and be able to distinguish them from other problems, and then to know if you do have an overdose, what you can do to correct it. So the first thing is getting the rate right, preventing an overdose in the first part. We have a lot of recommendations. We've given you some resources for rate recommendations on a lot of different crops. There's just so much more information now than there was in the 80s when paclobutrazol first came out and we had 2-inch poinsettias. We've come a long way. And once you determine your rate, Brian Krug actually has a calculator, an online calculator, to calculate the mixing rates so you can reduce your errors there. So you can get that information straight off of his website. And when you have the optimal rate, of course, you're going to have control of plant stretch. You're going to have something that's more proportional to pot size, which consumers will tell you, or the consumer research tells you, that that's very important to the customer's perception of quality, is that that plant is in proportion to its pot. Brian talked about how the plants were darker green, and that also improves the appearance of the plant and makes them more saleable. But when that rate gets too high, then you have excessive growth control. It can be an obvious stunting, it can just be a lack of leaf expansion, or you just may have a flower delay or a smaller size of those flowers. Some of these, most of the time when we have stunted plants, we also have stunted roots. So we also have issues with establishment in the landscape. This is an example of pansy. You can see that we have a little too much control with the PGR. If you look closer, you can see just how tight those growing points are. They really shouldn't be quite that tight. And one very typical response to PGR overdose is this curling of the peduncles. The flowers don't stand up straight and flat like they should. And also an untreated flower here, the treated flowers are typically smaller. For an overdose, they're smaller, and they may actually be bleached out. This is much less color than we see with the untreated plants. But the flower size is not always affected. Brian just showed this picture with the Easter lilies, and we actually had some Asiatic lilies that our students in our plant production class grew that made nice little tabletops. But the flowers were the same size as normal. Didn't affect flower size at all. So there are a lot of options here. What we want to see is a consistent effect, and sometimes that consistent effect is an overdose, sometimes it's not. But more commonly, when we get into drenches and see an overdose, it's going to be a volume issue with the application itself. So you want to be very careful, again, in all cases, sprays or with your drench applications, that that volume is consistent. So I'm going to show you a few of Brian's slides. If you don't know Brian's reputation, he's the one who takes pictures of dead and dying plants. And he has several symptoms here of distorted growth from other causes other than plant growth regulators. And I think probably one of the more common ones that I've seen in the greenhouse has been herbicide drift. Herbicides used outside the greenhouse that have caused a lot of damage to plants when it gets into the greenhouse, and sometimes herbicides used inside the greenhouse when they shouldn't have been. But herbicide drift, particularly in this case it was 2,4-D, can be very wide ranging. You can get pesticide drift up to a mile for something as volatile as 2,4-D. So you want to be aware that that is a possibility. Certainly be very careful with any herbicides around your own operation and anything around the fans. If you're getting damage to your plants near fans or vents, then that's one of the things to consider. Go out and look at what's going on around your operation on the outside. Now, sometimes the problem can actually be nutritional, and you may see boron deficiency causing basically death of the growing terminal, and when a new growth starts, you'll get some very distorted growth, and we've seen that both on other crops as well as on, this is Gerbera daisy seedlings. You can see it starts very young in the crop, just very distorted, thick growth. And then we've also got mites to contend with. This is an example of broad mites on New Guinea impatiens. You can see the type of distortion that they're feeding in the terminals has caused. Again, these are all symptoms that might be confused with the distortion caused by a PGR overdose. You need to recognize what these are. Look further, particularly if these are random plants that are showing this as opposed to an entire crop or sections of the crop. They may more likely be another cause, another abiotic cause, instead of the PGR overdose. So if you have a PGR overdose, what can you do about it? There are some options, and the options depend a bit on how bad the problem is. If it's not a significant growth reduction, not really badly stunted, you might be able to push them with just more better growing conditions, more fertilizer, especially if you're looking at the ammoniacal nitrogen or add some additional phosphorus in there. You can increase the growing temperatures. Again, you just want to try to push the plants. If that doesn't work, then you need to look at applying these growth stimulating PGRs. We talked about those before, the benzoadenine or the combinations with the gibberellins. The benzoadenine by itself is not going to do a lot for overcoming the stunting. The gibberellic acid, this again is very, very, very potent. I've seen it used for enhancing growth due to an overdose, but it's really difficult to work with because it's just so potent. So what we really recommend is the combination of the BA plus the GA4 plus 7. This GA itself is not as active in growth promotion as a GA3, and this is just easier to work with. So if you stay with the Fascination or the Fresco, again, it's very difficult to come up with the rate to use if you're going to do a single application. So we really recommend that you start low, start with a 1 to 3 part per million, as we mentioned earlier, and just sneak up on it. You should see a response within 5 days. If you're not seeing that response, then you can come back in with some additional growth promotion product, Fresco or Fascination. Both of these are labeled for that purpose, and we recommend, again, low rates, multiple applications as necessary. Right, in summary, just a few things to keep in mind. Double check your math. Use the calculators that are available to you and make sure you're applying the proper volume so that you're actually getting the correct dose. Remember, we're talking about rate, the parts per million, times the volume gives you the dose that you're actually applying to that plant. Be able to recognize and differentiate between different types of symptoms, different distortions on the foliage, so that you can get to the true cause of the problem instead of treating something that's not there. If corrective action is required, use the tools. Fertilization, temperature is certainly where you want to start. And if that doesn't work, then you can work with the plant growth regulators to overcome that stalled growth. So like I said, this was basically a collection of topics that we wanted to put out there to you to get you thinking about or give you some updates on some of our research. And I'd be happy to take any questions now.
Okay, Joyce. Just one shameless plug for myself. Joyce mentioned the PGR calculator that's available online. We also have that as an iPhone, Android, and BlackBerry application, so a native app for those devices that you can go to your respective app stores and find that.
Thank you for pointing that out.
No problem. Okay. So a question about can PGR sprays increase insect activity?
That's a good question. We have done a little bit of work. I did a little bit in Georgia looking at insect activity on PGR treated plants. And we typically found that there was less activity, particularly when we look at the cuticles and the leaf structure, the increase in chlorophyll, the smaller cells, all of those make them just a little less attractive to sucking insects or piercing insects. So I can't say there's been any definitive studies on that, but the preliminary work that we did found that it just made the plants a little less attractive to the insects. I would use them instead of an insecticide. Not saying that, but you may get a little bit of benefit there as well.
So this next question has to do with the pH of the substrate and pH and the PGR activity. In an example given, do you think that the plants that were grown at a pH of 4.5 were smaller because of the lower pH rate was suboptimal for the plant growth, or do you think that is because of the activity of the PGR at that substrate pH?
Well, if you look back at that picture, we have the plants growing under those conditions, under that 4.5 pH. And the plant that was not treated with Ethifon was full size. There was no effect on the plant growth if we did not add the cholate. So yes, for a very long term, yes, I think the pH of 4.5 is going to be suboptimal and will affect growth. Over the course of this experiment, which was an 8-week experiment, no, that did not affect plant growth. And what you saw in those pictures was an effect of the Ethifon itself.
Okay. Let me